In this lesson, we are going to discuss the domain and range of a function, a relationship. So remember, in a relationship, it's like a rule where you have something equals, and you could put whatever rule you want, right? So I could triple a number, then add 5. That gives me my output. So the numbers I choose for x are my input. For example, I could choose 2 for x. And what I get is my output. And so when I choose 2 for x, I get 11 for y, right? So the input are all my x values and the output are all my y values. And so what we're going to look at today is we're going to talk about, well, what are all of the input values that I'm allowed to use, that are possible in my rule, right? And my output will be, well, what are all of the possible outputs that I could get? And the possible inputs will be the domain of the relationship, and the outputs will be the range. What could I get? What's the range of output for my relationship? For example, if I give you y equals the square root of x. So looking at y equals root x, you can see here where my input is restricted because I cannot take the square root of a negative. So my values of x have to be 0 and greater, right? I can take the square root of 1, I get 1. I can take the square root of a half, I get a quarter. I can take the square root of any number greater than 0, but I cannot take the square root of a negative. And at the same time, what I'm getting as my output is also restricted, because if I'm square rooting 0 and greater, the smallest value for y would be 0 and greater. So this is a look at where, when we have a relationship between two variables, what we're putting into our rules could be limited, and what we're getting out of our rules could be limited. So we're going to look at how we can write what these values are, calling them the domain of the relation, the set of all possible values which can be used for the input, and the range of the relation, which is the set of all possible values for the output. So let's take a look at this. In words, I could say the domain is a set of all real numbers less than 6. So 6 is considered my boundary point. It divides all of the solutions and the non-solutions. So I'm going to be putting a circle at 6. I'm not going to close in the circle, because when I close in the circle, the boundary point is included. If I leave the circle open, the boundary point is not included. And it says less than 6. So 6 is not included, but anything less than 6 is included. So I draw an arrow towards the smaller, all the numbers smaller than 6. Or I could say all real numbers between -5 and 7. So all real numbers between -5 and 7 has two boundary points, -5 and 7, and all the numbers between. Now I also have the word that says inclusive. So inclusive means you include those boundary points. So I'm going to color them in. So how would I write this mathematically? All numbers less than 6. You would say all of my numbers, if it was domain, you would say all of my numbers less than 6. If I wanted to write between -5 and 7, I have to have a way to show that it's bigger than -5 and at the same time smaller than 7. So the way I do this, if it was range, for example, and we're using y, I would say all of my values I'm getting are greater than or equal, since it's inclusive, to -5, and at the same time it's smaller than equal to 7. So there's ways to write where it falls between two numbers. There's ways to write when it falls on just one side of the boundary or the other. All right? Sometimes our data is not continuous. It doesn't represent all numbers on one side or all numbers on the other side. Sometimes our data is discrete, right? So it jumps from value to value. So for example, if these are the only data I have, these 4 points, the domain of my relationship is just the x coordinates. So I just list and I say equals. I don't say greater than or less than because it's not a continuum of values. I just list all the x values that I can use. And so the range, I just list all the y values I can use. If you notice, I get y twice, the same value of y twice. I get 1 and 1. I don't repeat it because it's just telling you what I could get. So I say I could get 1, or I could get 2, or I could get 4. I'm just listing my y values. So you list them in the order of smallest to largest, and you don't repeat. When it's discrete data, you use an equal sign. You just list the values. All right, so let's practice the formal mathematical set notation way of writing domain and range. So if you were to open up a textbook, this is one of the ways, most common ways you would read the domain and range of a function or relationship. So we need to understand how to read this. So this would be the domain. How would we read this domain? Well, the first part, the x with the bar like that is read x such that, meaning we are going to talk about the values of x or the domain. And then the next part here is the part we understand, x is less than 6. And then the last little part here, x with that symbol and an r, is read this way. X is in the set of all real numbers. Okay? And so this means in the set of, or is an element of, because that shape is like an E, right? Greek letter E means it's an element of. So x is in the set of all real numbers. So basically, you can see in all of these set notations, it's the middle part that changes. So this is what we're going to work on. I will provide that outer part there in green, so the y such that y is greater than or equal to -5, given y is in the set of reals. Right? The green part I will provide as your template. You need to be able to insert the yellow part there, right? So this one would be red. Y is greater than or equal to -5. This would be x is greater than 0 and at the same time smaller than 7. And this one would be red. Y is greater than or equal to -5, so you would include the -5. It's greater than -5, but it's smaller than 1, which it doesn't include the 1 value, right? So it's everything in between, including this boundary, but not including the 1 boundary, okay? So different ways to write continuum: greater than, less than, or between. Those are the different ways we could be writing our domain and range. So if I was to give you a function like this, and I asked for the domain, so the domain is all the possible x values that fall on my function in my graph. So here's, you can see on this graph there's a whole bunch of x values. So since there's arrows, it doesn't stop. It just keeps going on forever and ever and ever, right? So when I think about the x's, you'll notice that the x's go left forever and right forever and never stop. So any x can be used. It's not greater than, less than, or between something. So in words, my domain is all real numbers. It can be anything, right? So what do I put in here? I don't put anything in there. So I just squish that together. So I would say x such that x is in the set of all real numbers. That's it. Whereas my range is my y, what I'm getting. And so I go up and down on the side here to figure my range. And you'll notice with range, it doesn't go down forever. There's a minimum output of -2. My y's will go down to -2, stop, and then go back up. So my -2 goes up forever. So what would it be? And since the graph touches it at -2, it includes the -2. So I would say it's all real numbers. I'm going to be lazy and say Rn for all real numbers greater than or equal to -2. And how would I write that mathematically in set notation? Y such that y is greater than or equal to -2, given y is in the set of all real numbers. Let's try another one. Domain. Domain, we go left to right. I stop at -3, but it goes on forever, and it doesn't include -3. So my domain would be greater than, but not equal to -3. So I'd say all real numbers, x is greater than or equal to -3. My range going up and down here, well, it doesn't go up and down. It stays on the same value, right? So I kind of think about if I wanted to take this graph and squish it like a pancake this way. If I squish it like a pancake this way and get rid of this dimension and only look it up and down, it becomes just a dot, right? And so my my range is just one value. I'm only getting 4. That's all I'm getting. So it's not continuous data, it's discrete data for my range. So I'm only getting 4 as my output. So instead of using all of this continuous data, I would just say that y equals 4. That's it. I'm just going to list what I get. Okay? Let's look at domain and range here. My domain, left to right, because it's x, I'm going along the x-axis, but I just go up here. And I go stop here at -3, and then, stop here at 3. So my x value will just keep going between 3, go backwards to -3, then goes forward to 3. So all of my x values fall between the continuum of -3 and 3. So it's all real values between -3 and 3, inclusive. Since the graph is touching it, it includes it. So how do you write that mathematically? Well, you write the -3 on the left, the smaller number on the left, the larger number on the right, and so you need to write that x is greater than or equal to -3, while at the same time being smaller than or equal to 3. Okay. Range, just do the exact same thing, but now you're working at the height of the circle. The lowest height is -1, and the highest is 5, and all of your y values go up to 5, down to -1, back up to 5, down to -1. I don't care about right or left for range, I just care about up and down, the height. Okay? Kind of like if you were on a Ferris wheel. How high are you? How low are you? Okay? For the range. So, how would I write between -1 and 5 inclusive? Well, again, remember the smallest number on the left, the biggest number on the right, and y is greater than or equal to -1, while at the same time being smaller than or equal to 5. Okay, so that's how you write between two values. So my domain here would go from -4 all the way to 1, 2, 3, 4, 5. It would go from -4 to 5, but since it's open dots, it would not include it. So it would go from -4 to 5. X would be greater than -4 and at the same time less than 5. My range would go from 4, since it's an open dot, it doesn't include it, and all the way down to my lowest point being 0. But since the graph is touching it at 0, it would include the 0. So it includes the 0, right? But it doesn't include there, because at no other point am I at 4. If this hit up to 4, then I would include it, but it doesn't. Okay, so now my range is going to be from 0 to 4, but my y includes the 0, but it does not include the 4 boundary point. Okay, so that's how you would write that one. So don't forget, when you have discrete data, if your data is not continuous, like a line, where in between there's infinity options. So if it's discrete data, you just, for the domain, you would list x equals, y equals. And when you list them, smallest to largest don't repeat. So for the x's, you would go through and go, oh, -3 is the smallest. Then I have 0, then 1. Then I have 3, and then 5. So you always have to order matters. Then for the y's, you start with the smallest. Oh, I have 2. I have it twice, but I only write it once. Then I have 5. Then I have 8. Then I have 9. So those are all of the possible outputs, and those are all the possible inputs. Your discrete data could also be on a graph by dots, right? Because in between those two dots, there's no data, right? So for the domain, you list. And again, domain on a graph, you look at the top and you list all the x values. This time it's not a continuous greater than or less than. You just have to list all those x values. So it's from -4, -3, -2, -1, 0, 1, 2, 3, 4. So there's lots of different x's. The y values, again, you would list them, but you go on this side. There's less y values, 0, 1, 2, 3, or 4. Those are all the possible y values, 0, 1, 2, 3, or 4. Right? So you list them that way with discrete data. Let's try last two here. So, pause it if you want, try it, then unpause it, see if you get them right. Here's the first one. The domain, go left forever, go right forever. So the domain, I would just squish it together. There's no stopping left, no stopping right because of the arrows on my graph, x such that x is in the set of all real numbers. My range, up and down, has a stop at 4, but no stop going down, so my range is y is less than. Since it touches it, you would include the boundary point, less than or equal to 4. All right, let's go to the next one. This one's a little bit more difficult. If I wanted to do domain, I go left as far as I can. And I notice that, for example, if I squished it down like a pancake this way onto the x-axis, there would be no break in my graph. This line would fall right about here. Right? If I squished them all together, this line would fall within this one. So we would have them all squished down just into this line. So it's continuous data. My data for domain would go from 1, 2, 3, 4, 5, -5 all the way to 1, 2, 3, 4, 5, 6. My domain would go from -5 to 6 inclusive because of the solid dots. So from -5 to 6 inclusive using my less than signs or equal to. So x is greater than equal to that and less than equal to that. My range, however, is going to be different. Because as I go up and down, there's a whole bunch of breaks, right? So if I was to squish it this way, this would just squish into a single dot, this would squish into a single dot, and this would squish into a single dot, right? If I squished it all into the y-axis, the dot would all just fall there. So I have discrete data for my range. My range, I'm only ever getting 3 outputs. I'm getting -4, 2, or 5. Those are the only options. So I'm getting -4, 2, or 5. And I don't need that part anymore because it's discrete. Y is -4, 2, or 5. Those are the only things I'm getting. All right, so domain and range is your set of all possible inputs, and range your set of all possible outputs.